Hey guys, this is Fozon, and in today's video we're going to be discussing the object class. Our lesson objectives: learn what the object class is and its importance, and then we're going to learn the methods in the object class that are relevant to our course. So although we haven't gotten to inheritance, I'm going to give you a brief introduction to what inheritance is through the object class. The object class is the superclass of every class, which means that every class is automatically extended from object, whether it be directly or indirectly through another class. This ties into inheritance because if every class is extended from object class, because the object class is the superclass, that means it inherits the methods within the object class. So the object class includes a bunch of methods that are useful for our algorithms. And if every class is extended from object, this implies that we can use the object class's methods in any class that we so desire. We can also technically extend from other classes as well, and we will inherit the methods of that class. To show you what I mean, let me give you a diagram. So as you can see, the object class is the universal superclass, and all the classes that you see displayed that are being connected to object are extended from object. So to explain inheritance, look at the relationship between person and object. A person is an object, however, an object is not a person. A bank account is an object, but not all objects are bank accounts. Plants are objects, but objects are not all objects are not plants. We see this relationship with builder and student with person. Builders can be people, right? Builders are people, in fact, but not all people are builders. A student is a person, but not all people are students. And then we see this relationship extend beyond person. So a builder is an object, but not all objects are builders. Not all students are objects. Not all objects are students, but all students are objects. So we could also extend this beyond just people. So checking accounts are a type of bank account, but not all bank accounts are checking accounts. A common misconception that we see with this diagram is that the superclass implies that it's the biggest class. It is not. The object class is actually the class that has the least amount of methods. And the reason why this relationship occurs is because what happens is that the person class inherits all the values that are in object and then extends beyond that, meaning that the person class has all the stuff that the object class has and more. So what can characterize a person? A name, maybe their date of birth. These are not values or instance variables that are not in the object class, but they're in the person class. But person class also includes the methods that are inside the object class. Therefore, the person class is bigger than the object class, because we can use the object class's methods and the person class's methods. In the object class, we could only use the object class's methods, not the person class's methods. We see this relationship with builder as well. Builder expands upon person, so it inherits the methods of person and object. But it also expands upon that. What are they building? What is their build site? These are not instance variables that are in your regular person, but they are in builder. Therefore, the classes that are at the bottom are actually your bigger classes, despite them being called subclasses. The superclass is just the class that is being extended upon. So the builder is being expanded upon person. You're expanding upon person. That is why these methods are bigger, these classes rather, are bigger than their superclasses. This is sort of a brief introduction to inheritance, and although we won't be going into these type of relationships, I want to show you how we can use any classes, how we can use the object classes method within any class that you build. So the object class includes a toString method, and this is the method signature for the object class. The object class is toString method. Public string toString. So public implies that it's accessible. String implies that it's returning a string, and then toString is the method name, and there are no arguments. And when you invoke this method, the method will return the string version of the class. There are two ways to invoke this method. So I declared a bank account and I name it Fozon and has another argument of 420. The identifier that we use is my bank. One way of invoking it is the normal way. Do my bank dot toString and then the parentheses. But in terms of the object class allows us to simply call the identifier and then this method gets invoked automatically. So we don't really have to add dot toString, open parentheses and close parentheses, because if we simply write the identifier, this method gets invoked. However, when we invoke this method, we're left with this, bank account at 1F blah 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 blah. And this is not really practical for us to use. It might be useful for the computer to use if you're going that route. However, for us, this really doesn't accomplish anything. So what do we do in this case? Well, we override it. So by overriding the toString method, we can basically have this toString method do what we want. This is the same logic that we use with the default constructor. When we create a class, the Java gives us a default constructor if no constructor is there. However, if we provide a constructor, then it overrides the default constructor that Java provides. So the default constructor for Java, what it does is that it sets name equal to null and then balance equal to 0.0. However, if we override that, we can have it set so the arguments determine what name or balance is, or we can determine what name or balance is if there are no arguments. So in this case, what we do is that we don't want to use the object class's toString method. We want bank account to have its own toString method. So what do? We declare the same method signature that is in the object class, public string toString, no arguments, open curly brackets and close curly brackets. And instead of the object class returning some type of computer science jargon that the computer can understand, it returns something more practical, such as name, and then the name instance variable, balance, and then the balance instance variable, which is much more appropriate for our program. The object class also includes an equals method, and this is the method signature. Public, it means that it implies that we can access it. Boolean, meaning that's returning true or false to the user. Equals is the method name. And then we have an argument. So object, another one is just an identifier that I use. Again, this can be substituted for another identifier that you think is more appropriate. But like I said, any object can be put in there, and then we can see whether or not if those two objects are equal to each other. And like I said, since all classes are stemmed from the object class, then all classes get this method through the object class. So every class that you make, even if you make an equals method or not, will have an equals method because it's provided in the object class. And since it's stemmed from it, it will be invoked when someone calls the equals method with the appropriate arguments. And we have two results when we invoke it. We either have a true value or we have a false value. When we use the object class's equals method, what happens? What happens is that the equal method will compare the two objects to see whether or not if they're the same object, meaning it will compare the memory location of which each of those objects reside. If the computer determines if the both objects are in the same memory location, it will make the assumption that they are the same object. It will also return false if the two objects are not the same object, meaning that if they compares the two objects' locations and it sees that they're stored in two different locations, then it will return false. As you can see, this is not the best option that we want to pursue with the equals method, as you will see in our next two slides. So let's look at the equals method in practice. Bank account BA1 is equal to new bank account with the arguments FA and 422. And then we create a new bank account. We have another place for BA2, and then we set it equal to BA1. What does this do? What it's actually doing is that this statement simply creates the object. This statement with the constructor creates a new bank account with the arguments FA422. Most likely those are our instance variables. But what BA2 does is that it doesn't create a new bank account because we don't create it through a new constructor. What do? We simply point to BA1. It doesn't create a new bank account, meaning that only in these two statements, only one memory location was allocated for this bank account. And BA1 and BA2 are pointing to the same memory location. So if we invoke the .equals method of the object class, then it will return true because these are ultimately the same object because they are pointing to the same object. However, let's look at this example. So in this case, what happens? We have one bank account and we create it with a constructor with the arguments FA and 422. But then we create another object, and instead of having it point to BA1, we use the constructor again and have the same arguments as BA1. These are literally the exact same object because the instance variables that we're assuming, these instance variables are exactly the same, right? We don't edit the program afterwards. And logically speaking, these should be identical objects. If we invoke the equals method, it should return true. However, when we invoke the equals method, it returns false. Why? Because what the object class's equals method is doing is that it's comparing the memory location for each object. It sees that BA1 is located in one memory location, and then BA2 is located in another memory location. Being that these are two different locations, it makes the assumption that these are not equal to each other. So what do we do in a case to show that this is actually equal to each other? Well, we can override it. So let's go to the compiler. So in the compiler, I have a bank account BA1 is equal to new bank account Foson 422.0, 420.0. We also have a bank account BA2, and we are simply pointing it to BA1. And then we made a third bank account, and instead of pointing it to BA1, we create a completely different new bank account with Foson 422, 420, the same arguments that we used in the first bank account. And just to show you what we have in the bank account class that we're creating an object out of, we have 3 private instance variables, we have 3 constructors, right? I say overrides the default constructor next to the one with no arguments, but technically speaking, the existence of any of these 3 constructors overrides the default constructor. We also have our accessor methods, and we have our mutator methods. I also have additional mutator methods because a more practical mutator method would add to checking and add to the savings accounts rather than simply changing it through a given value. But as you can see, I haven't implemented an equals or toString method. So let's see how they work via the object class. So there, just to make sure, there is no equals method, there is no toString method within my class. So it's getting it from the object class. It's extending it from the object class. It inherits it from the object class. So let's first do the toString method. System.out.println, and then we could do ba1.toString, and then semicolon. Let me make sure that this is saved, and let me make sure that this is saved. Let's see what it returns. And it returns us with this sort of programming jargon. Now let me show you that the same result appears without the toString invoking, because this automatically invokes the toString method if you call on the identifier. And as you can see, it returns the same result, meaning that's invoking the same method within the object class, the toString method. So what we can do is that we can add our own toString method. And by making our own toString method, what happens is that we ultimately override the toString method within the object class. So I have it set to public. Public means that we can access it, just like the other public methods that are available in this class. It's going to return a string, and the name of the method is TOSTRING. Through this method signature, we've pretty much accomplished overriding the object class's TOSTRING method. And let's return the name and maybe we'll omit savings and just simply send the checking. Actually, on second thought, let me add savings. Might as well. Since we're doing the TOSTRING method, we definitely should go all out when we do our TOSTRING method. So it will return this string when the TOSTRING method gets invoked. Let me save that. And let me run this program. And as you can see, we no longer have that computer science jargon. We have our TOSTRING method being invoked. And as you can see, we don't actually invoke it through the TOSTRING method. We can if we want to, but it's pretty much useless because, well, not useless, but we'd much rather call it through BA1, just simply the identifier. And as you can see, it converts the class into a string, literally its purpose. Now let's work on the equals method. So as I said before, we have, technically speaking, 3 bank accounts. However, we only have 2 memory locations allocated for these 3 bank accounts. So we have BA1 is equal to new bank account with these arguments. And then we have BA2, another bank account. However, what it does is that it simply points to BA1, meaning that we have one memory location that includes a bank account, but we have 2 pointers to that. We have 2 identifiers attached to it, BA1 and BA2. Then we have BA3, which has the exact same instance variables of the BA1 or BA2 bank account. However, the compiler, the object class's equals method cannot interpret that because it sees 2 different memory locations, and if it sees 2 different memory locations, it doesn't assume that it's the same. So we have to override it. But just to show you that it can't do that, let me show you how it works in practice. So we have BA1, and we're going to compare that to BA2. Now, what should the compiler return, since we haven't overridden the object class yet? It should return true because BA1 and BA2 are pointing to the same memory location. However, what happens when I change it to BA3? Now we have 2 different memory locations. And since we're invoking the object class's equals method, it should return false. And it returns false. Let's override it so that we can make this program more practical. So let me make a comment and make a new equals method. So it's going to be publicly accessible. It's going to return a Boolean value. And it's going to have a method name of equals. We will have arguments within our equals method. Let's make the arguments bank account. And then BA2 is the name of the bank account within our arguments. Now what do we want to do? Well, we want to see whether or not the values within this class's bank account, so the instance variables within this class, name, checking, and savings, is equal to the name, checking, savings within the second bank account. So let me make 3 Boolean expressions. So Boolean x is going to be condition 1. Condition 1 is going to see whether or not if the names are equal to each other. Now I'm going to put a comment there just for the sake of coming back to it, because when we're comparing strings, it's a little bit more different than comparing integers or doubles. Our second Boolean expression is going to compare the checking accounts of the 2 respective bank accounts. So it's going to see, alrighty, what is the checking accounts value in this class. And then it's going to see whether or not, it's going to see if that is equal to the checking account value within the second bank account, or the ones that are in the arguments. So how do we do that? Well, we first call it by its identifier. Oh, that's not it. And then since it's a private instance variable, we have to access it through the getChecking method. So getChecking method of the second bank account, the one that's in the arguments. We're going to do the same thing, but with savings, and we're going to label it condition 3. This dot savings is equal to ba2 dot get savings, and that should return a double. Alrighty, that's cool. And then what we're going to do is we're going to create an if statement, and it's going to see whether or not these three statements are true at the exact same time. So what logical operator would we use? We would have to use the double and operator, double ampersand operator. And if this is true, it's going to return true, meaning that if all these values are equal to each other, meaning that if all these conditions are true, that means that all the instance variables are the same between BA2 and the current class that we're comparing it to, and we return true. Else, we can return false. Technically speaking, we can simply just omit this else statement, because if it returns true, it's not going to even look at the next statement after that. But if it does come to the point where it reaches past the if statement, then we know that this condition evaluated to false. So let's just put return false rather than putting an else statement. Alrighty, so now I left out condition 1 for a good reason, because there's a reason why you can't do this with the string values, because string is not a primitive type, unfortunately. So what is the string? Well, since the string is not a primitive type, that means that it's its own object, which also means that it has its own dot equals method. The string is actually a class that contains its own dot equals method. So let's get the string from BA2. Let's get the name from BA2. Let's call it string BA2 name. And we're going to get that name through the getName method. So now we have a string, but now we want to see if this string is equal to the string currently here. So what do? We invoke the dot equals method of the string class, and we do that by doing ba2 name equals, and then in parentheses we're going to put this dot name. Okay, the color is implying that I shouldn't have any compiling issues. So just to avoid any, issues right now regarding logic, what I did was that I made the method declaration, but instead of having an object argument, I replaced it with a bank account argument. I accessed the name of the BA2 object, the argument that we're comparing it against. And for the first condition, what we're doing is that we're comparing the name, the string values, and since string is not a primitive type, we use the dot equals method of the string class. This is foreshadowing to our strings video. And since the string class has its own equals method, we can invoke it to see whether or not if two strings are equal to each other, and this will return a true or false value. For the primitive types, however, we can use the simple double equal sign. So we have the condition 2 that checks to see whether or not this checking account is equal to the checking account within the arguments. It also checks whether or not this savings account is equal to the savings account within the arguments. And then as long as all the conditions evaluate to true, as emphasized through our double and sign, then it will return true. Otherwise, if it doesn't return true, that means we know that they're not equal to each other. So rather, they're not all true. One of these has to be false, and it returns false. It's not the same object. Let's see if this works. So since I overrid it, this should remain the same. BA1 should equal BA2. And it returns true. However, what happens when we replace BA2 with BA3? As you recall, before we made, or rather overrode the equals method of the object class, it was returning false. Let's see if it now returns true, like we want it to. And as you can see, it now returns true. We've now accomplished how we can override methods with the object class. And hopefully this should give you a brief introduction to how inheritance works in our future videos.